This instructional video will demonstrate how to use Hess's Law to determine the heat of formation of a target reaction given a set of working reactions where their heats of formation are known. First step is to make sure that the target reaction given to you is balanced, as this one is, and then we can begin to determine what manipulations are necessary to the working reactions to make sure that we get the correct number of moles as well as the correct location for each part of the target reaction, meaning that things are reactants where they're supposed to be and products where they're supposed to be. So the first thing we can observe is that if we take reaction B and do nothing to it, this will give us our first reactant. So it's a simple matter of just copying that over. For the next reactant, our 2 moles of hydrogen, we're going to be using reaction A, and we will have to multiply that by 2. This means that everything in reaction A must be doubled. And this will give us then 2 moles of hydrogen gas as a reactant. Two times 1/2 will give me 1 mole of oxygen, and 2 times 1 mole of water gives me 2 moles of liquid water. For the final piece, to get methane as a product and have only 1 mole of it, I actually need to reverse reaction C, which means I will multiply the entire thing by -1, switching reactants for products and products for reactants. And so this act will then give me what I need, which is 1 mole of methane as a product. And so this reversal then looks a lot like a combustion reaction, only going in reverse. But this gives me everything that I need in the correct combination. And so now the next step then is to combine everything and figure out what we can cancel. So for that I'll use color for emphasis. Here I have 2 moles of oxygen as reactants and 2 moles of oxygen as products. These will cancel. Using the blue, I can circle that I have 1 mole of carbon dioxide as a reactant and 1 mole of carbon dioxide as a product, and these will cancel. Finally, using the green, I can circle that I have 2 moles of liquid water as a reactant to cancel out 2 moles of liquid water as a product. Because these cancellations all work, I can write out the overall reaction, which we find now is precisely the target reaction that we were going for. Because this passes the check step of retrieving our target reaction, now can I take the manipulations that I did to each of the individual reactions and apply them to their heats of formation. At this point, it is simply a matter of summing up everything. So I will have, for reaction A, 2 times delta H for reaction A. The contribution from reaction B is 1 times the delta H for reaction B. The contribution for reaction C is -1 times the delta H for reaction C. I can substitute in the values and carry out the full calculation, and I find a value of -85.09 kilojoules for the delta H of the target reaction. So using Hess's law in this way allows us to determine an unknown enthalpy change for a target reaction using what we know about reactions that are already given to us.